Hi everyone. As part of today's problem, let's try to understand and solve the square root of a number. The problem statement is pretty straightforward. We will be given a positive integer called number. Our aim is to find the square root of this number rounded down to the nearest integer. You are not allowed to use any built-in libraries. Basically, we need to implement it all by ourselves. Let's take the example of 9, right? 9 has a perfect square root of 3. Whereas if you take the example of 8, the exact square root of it would be 2. Some floating point result. So we need to round it down to nearest integer. So the square root of 8 is nothing but 2 according to this problem statement. Ideal and the better way to solve this problem is with the help of binary searching technique. So how exactly we do that is, ideally the square root of a number will definitely lie from 0 till the number that we have been given. So even though we don't see a sorted array of numbers, since our square root will lie anywhere in this series of values, ultimately we are searching for our result inside a sorted array of numbers. That's the reason why start will be at 0, end will be at 8. We will calculate the middle, we get middle. So the middle index is nothing but 4. Now if we try to perform the 4 square, the result that we get is 16, but the square root that we are trying to find is for 8. So 16 is greater, right? That means the square root of it should be somewhere on the left of the middle that we have computed, which is in this range. So here end basically will become pointed to 3. Again we will calculate the middle and it is 1. If I try to perform 1 square, the value will be 1. We are looking for 8. That means it will be somewhere on the right of the middle. So start will basically get updated to 2. So again we will calculate the middle. If I try to perform 2 square, we basically get 4. That means, so it will be somewhere on the right. So start will basically get updated to 3 and end is already at 3. Again we will calculate the middle. 3 plus 3 by 2, which is 3 itself. If you perform 3 square, 9. So it must be somewhere on the left. So end will basically get updated to middle minus 1, which is nothing but 2. Now at this point of time, start is pointing to 3, end is pointing to 2. So overlapping is done. We can't do anything. In the end, we need to return whatever the value we have in the start minus 1 to handle the scenarios where we don't have the perfect square root. So this will basically return the nearest integer square root of that particular number. Okay, so that is a binary searching specific technique for solving and finding the square root of a particular number.